In this video, we're going to be looking at question 25 of 2021 Junior Mathematics Olympiad first round. So we're asked to find how many integers there are between 100 and 999 inclusive that consist of distinct odd digits. So by distinct, they mean different, right? So the numbers we're looking for are numbers like 753, because 753 has 3 odd digits, and the odd digits are all different. Or maybe numbers like 137, because 137 is made up of 3 odd digits, and those 3 digits are different. So a number like 121 will not be included, or let's say 123 will not be included because it has an even digit. That's the 2 in it. Or maybe 113, this will not be included either because 113 is, yes, all the digits are odd, but some digits appear twice. I want all the digits to be distinct, right? Yeah. So that's the kind of, so they're asking us to count how many integers there are, like 753, 137, and the others. So this is a counting question, right? So notice that we're meant to form a 3-digit number from the 5 odd digits that we have. So let's say we have something like this, right? So we have 3 spaces that we're meant to fill with 3 numbers that will be odd digits and that will be different. Okay, so the odd digits that we have are 1, 2, 3, 5. So the odd digits we have are 1, 3, 5, 7. So these are the odd digits that we're meant to use. And we're meant to use these odd digits to fill in these spaces that we have here, such that no odd digits appears twice. Okay, so for the first digits of this number we're going to form, right? Notice we have 5 options for it. So for this first digit, we can use any of these 5 letters to place there. For example, we can choose to have 7 there, right? Okay, so let's just say we have 7 as the first digit, right? Then when we look at the second digit, notice that we won't be able to use 7 again. So we no longer have 5 options. Rather, we now have 4 options to pick from. That's all the odd numbers minus the number that we picked initially, right? So let's say we pick 3 at this point now and put 3 here. Notice that now we no longer have 4 options again for the last digit because we already used 2 of them. We can only use either 1, 5, or 9. So we have 3 options for the last digit. So maybe let's say it's 9, right? And we're done and we have a number 739 that satisfies the condition we're looking for. Okay, so generally, since we have to fill in 3 spaces with 5 odd numbers and we don't want any odd number to appear twice, the number of ways that we're going to be able to accomplish this is going to be, so for the first digit, we're going to have 5 options. We can choose either of 1, 3, 5, 7, or 9. So for this, we'll have 5 options. Then for the second digit now, remember, we won't be able to use the digits we picked in the first, for the first space, right? So after picking the digits we have in the first space, we're going to have 4 more odd digits that we'll be able to use in the second one. So for here, we'll have 4 options. And then for the third one too, since we have used 1 in the first, that's in the hundreds digit, and 1 in the tens digit, you're going to be left with just 3 odd numbers that you'll be able to place on this third space, right? That's the unit digit. So you have 3 options for this. And since these are like independent, or not really, but yeah, since you have 5 options for the first digit, 4 for the second digit, and 3 for the third digit, you're going to have a total of 5 times 4 times 3, which is 60 such odd numbers. So there are going to be 60. So there are 60 odd numbers between 100 and 999 that consist of distinct odd digits. Yeah. So that's how to go about solving question 45 of this year's junior first round exam.